In this video, I will demonstrate how to perform a chi-square test for independence. So what we're working with here is data. We have two variables. Will both be categorical or nominal scale variables. And so typically what we're doing is we're trying to determine the association between what you could call an independent variable, like gender, for example, and then an outcome variable, like the number of hours they sleep, placed into categories. And so if we wanted to determine the effect of gender on the number of hours sleeping, or the association between those two, we could perform a chi-square test for independence. So each variable has to have a minimum of two possible categories. In this case, our gender variable has two categories, and our sleep category, or outcome variable, has four categories. And so this would be what we'd call a 2x4 chi-square test for independence. But again, it has to be a minimum of two, and it can be larger than that as well. And it's just going to depend on how many categories you might have in each variable. And so that's what we're going to be doing, attempting to see if there's an association with or an effect of potentially gender on sleep. So in order to do that, we're going to go to the analysis menu. We're going to go to our non-parametrics menu, and we're going to find the chi-square test of independence and click on that. And so you have an option to either enter data manually into a contingency table. So if you already have a contingency table created, you can enter data manually into a kind of constructed table, or you can have Intellectus do it for you directly from your data set. So I'm going to choose to have Intellectus do it directly from the data set. So I'm going to select that option. And typically the variable number 1 is going to be what we're considering to be our independent variable. And so in this case, that's going to be gender for us. And we're going to click confirm. And then our second variable, variable number 2, is going to be our outcome. In this case, sleep. So we're going to click confirm. Sometimes they're interchangeable, but very often when we're doing this test, there is kind of a temporal order to this, or in the fact that we have one variable that we're considering to be the predictor or the independent variable, and then we'll have an outcome. So we want to order them in that way, and then that way you'll have a contingency table produced that will look what a traditional contingency table will look like. So once we've entered our two variables, we go ahead and click calculate, and we're going to go looking into our raw output here. And so you can see here it will give us the observed and expected counts for each combination of our two variables. So in this case, we've got male and female. So we've got two columns, and then we've got four possible rows or categories. And so you'll see an observed count for the males sleeping less than 6 hours, for example. And then you'll see an expected count as well. So this is obviously something you'd report in your descriptives, but what we want to try and understand is, does being a male or female have an effect on the number of hours that you're sleeping as exhibited by these categories? And so what we're going to do is we're going to go down to the chi-square test here, and we can see our chi-square value. We can see our degrees of freedom, and here's our p-value. So our p-value is greater than 0.05. So we would be able to say that there is not a significant difference or a significant association between gender and number of hours that you sleep. So the null hypothesis would be there would be no association, or there would be no difference in the expected and the observed counts or frequencies. And in this case, even though there are differences, these are not considered to be significant in the sense that they may be random. There doesn't appear to be a systematic difference between the observed and the expected. So we had a non-significant result here, so we could make the conclusion based upon this sample that gender does not seem to have an effect on the number of hours people identified that they sleep. We also can look at Kramer's V, which is a measure of effect size. Even though we have a non-significance, we can still examine Kramer's V. And what is considered to be small, medium, or large magnitude of effect for Kramer's V depends on the degrees of freedom. And so for degrees of freedom of 3, there's kind of a lower threshold for effect size to be considered large. We have an effect size of 0.48, and because we have one of our variables having 4 categories or more, we use the degrees of freedom criteria of 3 to determine the strength of the association. And so when we have a degrees of freedom of 3, any Kramer's V value greater than 0.29 is considered large. And so we can see here that we've got 0.48. So even though we have non-significance, and you could argue that we have kind of a trend towards significance here, 0.08, we have what would be considered to be a large effect. So this would indicate to me that our sample size perhaps needs to be a little bit larger. And then we also have a few cells in which there are 0 observed counts. And so that tends to kind of throw off our ability to be accurate as far as the significance we're seeing. And so when that happens, we can fall back to what's known as the Fischer exact test. And what this does is counteract the fact that we have some cells that have less than an expected value of 5 or an observed count of 0, and so of 1 or 0. And so typically we like to see the expected counts be at least 5 for the majority of the cells, 80% of the cells. And so when they're not, like it is in this case, we can use the Fischer's exact test to counteract that. And so we can look at the p-value of Fischer's exact test here, and we can see that it still shows non-significance. We've got a 0.095 value, which is greater than 0.05. So both the chi-square test for independence and the Fischer exact test are showing non-significance. Sometimes if we have non-significance with a chi-square test for independence, and we've got that situation where we have some cells that have low values, either expected or observed, sometimes the Fischer exact will show significance. And so it's a good way to kind of counteract that effect of low expected values. But we can see here that both of these tests show non-significance. So we can conclude that in this sample that gender does not seem to have an effect on the number of hours somebody sleeps. So hopefully you'll find this video useful, and good luck using this in your own research.